السلام عليكم ورحمة الله وبركاته الأبناء الأعزاء. Let us continue our discussion for inverse trigonometric functions. Alhamdulillah, we finished 6 functions. Now we'll take some examples to understand very well these functions. Now please open your lecture notes and on time discussion for page 23. As you will see, exercise set 2. Okay, as you see, find the derivative of the following functions in the simplest form. First one, we have y equals sine minus 1 3x plus 2. As we said before, if y equals sine minus 1 some function, hence d by dx for sine minus 1 this function equals 1 over 1 minus square root of 1 minus the squaring of this function d function by dx. So in our problem, dy by dx or y dash equals 1 over 1 minus 3x plus 2 all square times the derivative of 3x plus 2, which is 3. Second problem, y equals sine minus 1 root x minus 1. Therefore, dy by dx or y dash equals 1 over 1 minus square root of x minus 1 all squared times d by dx for square root of x minus 1, which is 1 over, this will be cancelled, root will be cancelled with the squaring, so we will have x minus 1, so we have 2 minus x, 1 over 2 root x minus 1 times 1. Okay, why this is the derivative of the root? As we said before, when you are finding this derivative of a square root, it is 1 over twice the square root times the derivative of the function inside the square root. So 1 over twice the square root times the derivative of the function inside the square root. As you see, inside the square root we have x minus 1. Its derivative is 1, so it's finished. Now we have y equals square root of x tan minus 1 root x y dash. This is the product of functions. First one is root x, derivative of the second one 1 over, this is tan minus 1, and as we know, d by dx for tan minus 1 some function, this equals 1 over 1 plus this function squared, derivative of this function with respect to x. Now let us proceed for the given function. Let us proceed for the given function. So x root x times derivative of tan minus 1 root x, which is 1, plus root x all squared times the derivative of root x, which is 1 over 2 root x. As you see, this will cancel this, plus tan minus 1 root x times the derivative of 1 of root x, which is 1 over twice root x times the derivative of x, which is 1. Okay, so in simplest form we have 1 plus x, there is 2, plus 1 plus tan minus 1 root x divided by 2 root x. Question number 4, y equals sine minus 1 root sine x. So y dash equals 1 over 1 minus root sine all squared, derivative of root sine 1 over twice the root times the derivative of the function inside the root, which is cosine x. Simplify 1 over 1 minus sine x to cosine x root sine x. We can make only one root, which is cosine x over twice root sine x minus sine squared x. Question number 5. Y equals tan minus 1 2x. So y dash equals 1 over 1 plus 2x all squared times the derivative of 2x, which is 2. So simply it's 2 over 1 plus 4x squared. As you see, very simple piece of cake. Now go to page 24. This was problem 5. This now problem 6. We are given y equals square root of a squared minus x squared times sine minus 1 x over a. Product of function y dash equals the first times the derivative of the second root a squared minus x squared 1 over 1 minus x over a all squared times the derivative of x over a, which is 1 over a, plus sine minus 1 x over a. Derivative of the square root is 2 1 over 2 square root of a squared minus x squared times minus 2x. Simplify. This will be a squared minus x squared over a squared. So we'll have in the numerator a, we'll cancel with a. So we'll have a squared minus x squared times 1 over a squared minus x squared plus sine minus 1 x over a. 2 with the 2 plus minus, so we have minus here, and we have x over a squared minus x squared. Finally, this with this is 1, and we have minus x over a squared minus x squared sine minus 1 x over a. Piece of cake. Second problem is number 7. Y, second problem in page 24. Y equals tan minus 1 2 over x times cosine x squared. Also product of two functions, no problem. Y dash equals 1 over 1 plus 2 over x all squared times minus 2 over x squared. This is the derivative of 2 over x times cosine x squared plus tan minus 1 2 over x times the derivative of cosine, which is minus sine x squared times 2x. Simplify. As you see, this will be 4 over x squared. This will cancel this, and we'll have here x squared. So x squared plus 4 and minus 2 in numerator cosine x squared. Here we'll have minus 2x tan minus 1 2 over x sine x squared. Question number 8. Y equals x over sine minus 1x plus tan minus 1 x over x. Never say this is x times sine x. Never. Sine minus 1 is this, not a power, this is a notation. So this completely wrong, this is a fatal mistake. So y dash equals, this is a division, as you see, sine minus 1x all squared, sine minus 1x times the derivative of x, which is 1, minus x derivative of sine minus 1, which is 1 over 1 minus minus x squared. Here plus, someone can say this is 1 over x times tan minus 1x instead of division, no problem. So we'll have 1 over x times derivative of tan minus 1, which is 1 plus x squared, plus tan minus 1x times derivative of 1 over x, which is minus 1 over x squared. Simplifying, he asked us for simplest form, so we have to make all the possible simplification. Okay, someone may say divide this by this, y dash equals divide this by this to obtain 1 over sine minus 1x, no problem. And this will be divided by this to have minus x divided by sine minus 1x all squared times square root of 1 minus x squared. Here 1 plus x squared. Here minus tan minus 1x over x squared. Okay, now for problem number 9, y equals sine minus 1 x power 10 plus root x plus cosine minus 1 x power 10 plus root x. Okay, as you see sine minus 1 cosine minus 1 for the same argument. As you know, as a whole, this is an angle, while this is a sine. This is an angle, this is a cosine. As we know, since we are sine minus 1 for some function plus cosine minus 1 the same function, the derivatives will be the same, except the first will be positive and this will be negative. So we will have here some quantity which is positive plus the same quantity but with negative sign. So finally it will be 0 without actually obtaining the derivatives. We don't need it. It is a loss of time. You have to be brilliant. You have, as I told you before, please read the problem carefully, understand your question, so you inshallah you can solve it simply, inshallah. Okay, now let us complete. Y equals sine x sine minus 1x plus x tan minus 1x plus 20x squared plus no, it's not y equals some expression plus tan minus 1 y equals 2. This relation is called an implicit ضمني, an implicit, because we have a mixed relation between x and y. It is not a clear relation between x and y. It is not explicit. It is called implicit. All the problems before are explicit. Only this one is in an implicit form or implicit relation. Okay, we will differentiate it part by part, then we will extract y dash for one side and the other quantities in the other side. Now we have a product of two functions. The derivative of the first is we differentiate with respect to x. We differentiate with respect to x. Okay, so the first is sine x times derivative of the second, which is 1 minus x squared plus cosine x times sine minus 1x plus x times derivative of cotangent minus 1, which is minus 1 over 1 plus x squared, plus cotangent minus 1x. The third is 40x squared. The fourth is 1 over 1 plus y squared times the derivative function, which is y dash. The other side is 0. Now we take this to the other side and multiply by this to obtain y dash. So y dash equals all these quantities multiplied by minus 1 over y squared. Inside this square bracket, this one plus this one plus this one plus this one. Okay, sine x over root 1 minus x squared plus cosine x times sine minus 1x minus x over 1 plus x squared, finally cotangent minus 1x. Okay, what he asks for also. Okay, now enter page 25. Okay, differentiate with respect to x and simplify to prove some requirement. Okay, we are given y equals x times sine minus 1 x all squared minus 2x plus 2 root 1 minus x squared times sine minus 1x. We are required to prove that 1 minus x squared y double dashes minus xy double dashes minus 2 equals 0. Okay, we differentiate once. Y dash equals x derivative of this part is 2 sine minus 1x times the derivative what inside, which is 1 minus x squared plus sine minus 1x all squared times the derivative of x, which is 1 minus 2 here plus 2 bracket root 1 minus x squared, derivative of sine minus 1, derivative of sine minus 1 is 1 over 1 minus x squared under the root plus sine minus 1x, derivative of this 1 over twice the root, derivative of what inside the root minus 2x. Okay, let us simplify. This is 2x sine minus 1x divided by square root 1 minus x squared plus sine minus 1x all squared minus 2. Here this will cancel this, so we have 2 with the 2 minus, and outside we have 2. Okay, so we have x sine minus 1x divided by 1 minus x squared. This 2 cancels this 2, this part cancels this part, so we have finally y dash equals sine minus 1x all squared. Obtain y double dashes. Y double dashes is differentiate the left, differentiate the right. 2 sine minus 1x to the power 1 over 1 minus x squared multiply both sides by 1 minus x squared. So we have y double dashes times 1 minus x squared equals on the other side 2 sine minus 1x. Differentiate with y double dashes times 1 over 2 1 minus x squared. Here we'll have minus 2x plus y triple dashes square root of 1 minus x squared equals on the other side 2 over 1 minus x squared. Okay, simplify as much as you can. As you see, 2 with the 2, so we'll have minus x y double dashes divided by root 1 minus x squared plus y triple dashes square root minus x squared equals 2 over, multiply both sides by root 1 minus x squared to obtain, this will be 1 minus x squared y triple dashes, this will be minus x y double dashes, this will be just 2. This is what is required, exactly what is required, as you see. Required to be proved. Required to be proved. Okay? As you see, it's very simple, very easy. Just keep in mind the principal's derivatives so you can inshallah solve everything simply. Another one, y equals sine a sine minus 1x. Required to be proved 1 minus x squared times y double dashes minus xy dash plus a squared y equals 0. I want to make a looks for you in the last problem. As you see, in the required at the beginning there was y3 dashes, y2 dashes. Don't think that we have to obtain, we have to differentiate this 3 times, then 2 times, and put here this formula to be 0. No, never think like this. But differentiate once, then simplify. After simplification, differentiate once more. You will obtain y double dashes. Simplify, differentiate once more to have a relation, including y triple dashes, which is the required relation. We will follow this again. Don't put in your mind, you have to obtain y double dash, y dash, and put in this formula to prove that it is 0. No. Just differentiate once. Y dash equals, derivative of sine is cosine. Cosine what? A sine minus 1x times the derivative of what is inside sine, which is a over root 1 minus x squared. Simplify. Multiply both sides by the root. Okay? Y dash times the root equals a cosine a sine minus 1x. Okay? Differentiate once more. Okay? Y dash times minus 2x over 1 minus x squared. This is the derivative of the root. Plus y double dashes times 1 minus x squared equals on the other side, a is a constant, derivative of cosine is minus sine a sine minus 1x times the derivative of what inside, which is a over the root. Now this part is given as y, so we can replace this by y, cancel this, and this is y. Okay, multiply both sides by this root, here and here and here. So we have minus 2x y dash plus y double dashes times 1 minus x squared, because the root times the root, equals the other side minus a squared y. Okay, rearrange. We will have 1 minus x squared times y double dashes minus 2xy dash plus a squared y equals 0. This is what is required to be proved. Thank you. Finally, we have if y equals cosine minus 1 to tan minus 1x divided by 1 over x squared, proves that required to be proved 1 plus x squared times y double dashes plus 6xy dash plus 6y equals 0. Okay, first we multiply both sides by 1 plus x squared to make it simple form. So we have 1 plus x squared times y equals cosine minus 1 times 2 tan minus 1x. Okay, differentiate. It is cosine, not cosine minus 1. It's cosine. This is cosine, not cosine minus 1. Differentiate both sides with respect to x. Okay, 1 plus x squared times y dash plus 2x y equals minus sine 2 tan minus 1x divided by 2 1 plus x squared. Okay, simplify. Okay, 2 times 1 plus x squared all squared y dash plus 4x 1 plus x squared y equals minus sine 2 tan minus 1x. He needs a relation which contains y double dash, so we have to differentiate once more. Okay, no problem. 2 times 1 plus x squared all squared y double dashes plus this one will be 4, drop the power, times 2 will be 4. Okay, this will be 4. 1 plus x squared, differentiate what is inside, which is 2x. Okay, and y dash as it is. Okay, this actually will be inside this. If x entered inside, this will be x cubed. Okay, better than to differentiate 3 terms. It is only to differentiate 2 terms only. Okay, plus 4x plus x cubed times y dash plus 4 1 plus 3x squared y equals in the other side. The ratio of sine is cosine 2 tan minus 1x divided by 1 plus x squared. Oh, this is y, so this is minus y. Okay, simplify. We have y dash, we have y. Simplify in one side, so we have 2 1 plus x squared y double dashes. With this we will have this can be subtracted, x 1 plus x squared, so we have 4 and here 2, we have 6 x 1 plus x squared y dash. This will be enter the other side with plus sign, so we will have derivative. Oh, here we have 2. Here we have 2. So this is actually minus 2y. Okay, so this will be enter the side. We will have 4y plus 2y is 6y. This is 12. Okay, take 4 4 plus 2 6, 6y. Okay, and yes, 4 times 3 is 12. We'll take 6 common factor. Yes, I will obtain this. Finally, we will obtain 2 1 plus x squared 1 minus x squared y double. This is all squared, y double dashes plus 6x 1 plus x squared y dash plus here 2 plus this side, which is also 6 1 plus x squared times y equal 0. Okay, divide by 1 plus x squared, so you will have what is required to be proved. Thank you. شكرا جزيلا. إن شاء الله we'll meet in the next lecture إن شاء الله with a new topic إن شاء الله تعالى. والسلام عليكم.